Okay, let's have a look at the probability problems for TS EAMCET 2019. So they have asked these problems, and the first problem is if two unbiased dice are rolled simultaneously until a sum of number appeared on these dice is either 7 or 11, then the probability that 7 comes before 11 is these four options. So what we have to do is in this problem, look at this fact that either you get 7 or 11, otherwise you keep on rolling the dices. And these are unbiased dices. Unbiased dices are where you can get the face value of 1 or 2 or 3 or 4 or 5 or 6, and the probability of each of these is 1 by 6. This is called as an unbiased dice, and we have two of them and we are rolling them simultaneously. So what can be the possible options when you roll two dices simultaneously? Either you get like 1 1, or you will get 1 2, or you get 1 3, then you get 1 4, 1 5, 1 6. Then you can also get 2 1, 2 2, 2 3, 2 4, 2 5, 2 6. Similarly for 3 1, 4 1, 5 1, then you have 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. So in what cases will the sum be equal to 7? Here 1 6, 2 5, 6 1, and in the middle there will be, so for 7, let me write it down for 7. 1 6, 2 5, 3 4, 4 3, 5 2, 6 1. These are the only cases when the sum of the faces of the two dices will be equal to 7. And what will be the cases for 11? 11 will be just 5 6 and 6 5. That's it, only two. But in how many ways can we roll the dice? 6 into 6, it's 36 ways you can roll the dice. Okay, and for 36, when the sum is 7, you have 1 2 3 4 5 6 possibilities when the sum will be 7. For the sum equals to 11, there are only two possibilities. These are the total possibilities, which is 36. For the sum to be 7, there are 6 possibilities. For the sum to be 11, there are 2 possibilities. For sum to be something else, neither 7 nor 11. What are neither 7 nor 11? Like 2 here, 3 here, 4 here, 5 here, 6 here. Again 3, 4, 5, 6, 8. All of these are neither 7 nor 11. How many will these be? 6 and 2 is 8. 36 minus 8 is 28. So this is your event distribution table, where the total events are what? Total possibilities are 36, out of which there are 6 cases when your sum will be 7, and 2 cases when the sum is 11, and 28 cases when the sum is neither 7 nor 11. Now let's look at how to solve this problem. It says You have to keep on rolling the dice until it is either 7 or it is 11. So let us say when I roll the dice for the first time, I got 1 and 3. So this is sum of 4, neither 7 nor 11. So I will have to roll the dice again. Maybe I get 6 and 4 the second time. This is a sum of 10, neither 7 nor 11. I will keep on rolling the dice till I get either 7 or 11. Say I get on the third try I got 3 and 4. So this is the sum of 7 and I will stop here. Or say if instead of 3 comma 4 I got 6 comma 5 on the third trial, so sum is 11 and I will stop rolling the dice here. So I have to find the probability that I will get 7 first before I get an 11. Then the probability that 7 comes before 11. So how will that be expressed as a mathematical expression so that we can calculate the value of this problem? So probability of 7 before 11, it will be something like this. Say I roll the dice for the first time and I get the 7. That's it. I rolled the dice and I got 3 comma 4 on the first trial itself. So I'll stop right here. But if I don't roll 7 on the first attempt, what happens in the second trial? Say I got 6 and 4. So probability of something else, neither 7 nor 11. Now here I have to see that I need to roll 7 instead of 11. So I have rolled something else. Now I have to roll 7 again and my experiment will stop. This is the case of 2 dice is being rolled. Say on when I have done this again, say on the third attempt, I don't get 7, I don't get 11, I get something else again. I roll the dice again, I got something else again. And on the third time when I have rolled the dice, I get the 7. So I'll stop here. I have to keep on rolling the dice until I get the 7. So in this example, I have rolled the dice and I got the 7. So I'll stop here. Suppose if I don't get 7 on my first attempt, I got something else, neither 7 nor 11. Then I roll the dice again, I will get 7. So I stop here. If these two don't happen, I roll the dice, I don't get 7 or 11, I don't get 7 or 11 again, roll the dice, I get 7. So I stop in this one. Now if I start the experiment, I don't roll 7 or 11 one time, 2 time, 3 time, but I get the 7 on the fourth attempt. So I'll stop it here. So this will keep on going on till infinite times. This will keep on happening. I will get P of 7 plus P of L times P of 7 plus PE into P7 like this. So this will be a geometric progression. What is the probability of rolling 7? 6 by 36, right? So I have shown you the possibilities in which we can get a sum 7 here. 1 6 2 5 3 4 4 3 5 2 6 1. But the total ways in which you can roll 2 dice is 36. 6 times 6. Out of 36, there are 6 cases for which the sum is equal to 6. So probability of rolling a sum 7 is 6 by 36. What is the probability of rolling a sum which is neither 7 nor 11, which is 28 by 36? 28 by 36 times 6 by 36. Then if I don't roll 7 again and I have to roll something else again, so P of E, which is neither 7 nor 11, is 28 by 36, then 28 by 36 again, Okay, and after that I have rolled 7, so probability 6 by 36. Then again 28 by 36 times 28 by 36 and 28 by 36 and 6 by 36. And this will keep on happening till we roll a 7. So this will go up to infinity. How to solve this? This is now simply a geometric progression. I will just take 6 by 36 out. I will get 1 plus 28 by 36, which is my r raised to the power 1 plus 28 by 36 raised to the power 2 plus dot 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 dot. Okay, and sum of this geometric progression is simply 1 by 1 minus r. So 1 by 1 minus 28 by 36. So taking LCM is easy stuff. So 6 by 36 multiplied by 36 by 36 minus 8 is 8. So the answer is 3 by 4. The problem 1 was not easy. Okay. Now let's look at this problem 2. This is also not easy. It's not an easy problem at all. So you will have to think hard for this one as well. So these problems are not easy at all. A box contains 10 mangoes, out of which 4 are spoiled. So that means 6 are good. Now 2 mangoes are taken together at random. If one of them is found to be good, then the probability then the other is also good is which one of these 4 options? So let us approach it using sets. I will make sets to solve this problem. Say I have 10 mangoes, 4 are bad and 6 are good. The problem says I have taken 2 mangoes together at random, 2 mangoes, and one of the mangoes is a good mango. Then what is the probability? One of them is found to be good, then the probability that the other is also good is. So one mango is found to be good. What is the probability that the second mango is also good? So let us first look at when we just choose one mango out of the bag, not 2 mangoes, just one. If I am only choosing one mango, then the mango can either be good or it can be bad, right? When choosing only one mango. So it can either be good or either be bad. So when I choose one mango, it can be either bad or it can be either good. So this will be my sample space total 10. 4 will be for bad and 6 will be for good. So probability of choosing a bad mango will be 4 by 10 and probability of getting a good mango would be what? 6 by 10, because out of the 10 mangoes 4 are bad and 6 are good. If I choose one mango out of it, the probability that it will be good will be 6 by 10 and the probability that it will be bad will be 4 by 10. Easy. Now that I have taken 2 mangoes out of the bag at random without looking, so what are my possible options? Either that both of the mangoes will be good or both will be bad or one good, one bad. So out of these 3, only one can happen. So either both the mangoes will be good or both the mangoes will be bad. And one mango will be good, one mango will be bad. There is no other option than these three. So when I'm choosing, two mangoes are at random. So let us make a set for these. So when I'm choosing two mangoes, what are the total possibilities out of 10 mangoes? I can choose the first one in 10 ways. Now that I have taken one mango out of 10 out, I'm only left with 9 mangoes. I can choose one in 9 ways. So total 90 possibilities are there. So the total set will be 90. Now say if I'm trying to calculate the probability of both being good. What will be the probability of both being good? So first one will have to be good, so I can choose it in 6 ways. There are 6 good mangoes. I have taken one good mango out. How many good mangoes are left? 5. So I can choose one in 5 more ways. So over here, both good, 2 good mangoes. I will have 30 ways of doing that. Now let us look at both being bad. 2 bad mangoes. How many bad mangoes are there in the bag? 4. So I can select first one in 4 ways. Second will be in 3 ways. So total ways are 12. But we know that the total is 90, in which we can choose for like either 2 good or 2 bad or 1 good, 1 bad. So this will be the third one, 1 good and 1 bad. How many ways? 30, 42. 90 minus 42 is 48. You can also compute 48 in this way, 6 into 4 plus 4 into 6. How? I choose the first one as good one and the second mango as the bad one. Or I can choose the first one as the bad one and the second one as the good one. So this will be 24 plus 24, which is 48. Now the guy who has made the problem says one of the mangoes is found to be good. So this option is eliminated. So this is not in my sample space at all. I will not consider this because it says both are bad, but in the problem it's given as one mango is already good. Now you have to find out whether the second mango is good as well. So either you have this option or you have this option. Total options are 30 and 48, out of which he's asking for both to be good, that is the second to be good as well. So my answer should be 30 divided by total possibilities are 30 plus 48. Why am I saying 30 plus 48? Because the 12, which is the number of ways in which you can choose both bad mangoes, is gone because the problem already states that one of the mangoes is found to be good. So either we are here or we are here. And now he's saying what is the probability that the second mango is also good. So I need this in the numerator and the denominator will be total possibilities, which is 30 and 48. What is 30 plus 48 is 78. So 6 times 5 is 30, 6 times 13 is 78. So 5 by 13. This one. Now the third problem. 2 dice are rolled. We have already seen 2 dice rolled here, right, in the first problem. So we know what might be the output. Now the guy is saying if a random variable x is defined as the absolute difference of two numbers that appear on them, then the mean of x is this. Absolute difference. Let us make the table of the output on the 2 dices. So it may be 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, right? possible options. Then 2, 1, 2, 2, 2, 3. So this problem is really easy. It's just a lot of work. 2, 4. So you need to be very fast while doing this. 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. It's a lot of boring work in this problem. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, then 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So these are the 36 possibilities you can count. You will get 36 that you can get, that you will get when you roll 2 dice. The problem says I have a random variable x which is defined as the absolute difference of the two numbers that appear on them. So x is the absolute difference. Absolute difference is this, which is the number on the first dice, the number on the second dice. So phase 1 minus phase 2. So let us consider this case. 1 minus 1 is 0. So absolute difference is also 0. 1 minus 2 is minus 1, but it's absolute difference, so the negative sign disappears. Absolute difference is 1. Here absolute difference is 2. Absolute difference is 3, is 4, is 5. Over here absolute difference will be 1. 2 minus 1 is 1. Absolute difference of 1 is 1. Absolute difference, that is the mod of 1 is 1. 2 minus 2 is 0. Mod of 0 is 0. 2 minus 3 is minus 1. Mod of minus 1 is 1. Negative sign disappears again. So 2 here, 3 here, 4 here, over here. 2, 1, 0, 1, 2, 3, 3, 2, 1, 0, 1, 2, 4, 3, 2, 1, 0, 1, 5, 4, 3, 2, 1, 0. Now another boring work you have to do is count the number of zeros. 1, 2, 3, 4, 5, 6. So 0, x is equal to 0 how many times? Frequency 6 times. Okay. Now count number of ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You get 1 10 times. Okay, now look at 2. 1, 2, 3, 4, 5, 6, 7, 8. 2 appears 8 times. I know this is very boring problem, but it's very easy. So now 3, 1, 2, 3, 4, 5, 6. 3 is 6 times. Absolute difference 3 will happen 6 times. Now look at 4. 1, 2, 3, 4. Look at 5. 1, Where's 5 again? Where is it? Here. 2. 6. There is no 6. 6 will not happen. So our calculation is correct, right? This total should be 36. 16, 24, 30, 34, 36. Okay, good. So this will be the distribution of random variable x. 1 will happen 8 times, 0 happen 6 times, 2 8 times, 3 6 times, 4 4 times, 5 2 times. So mean of x is equals to the possible values of x multiplied by the frequency of those possible values divided by the total possibilities, which is equal to 0 times 6 plus 1 times 10 plus 2 times 8 plus 3 times 6 plus 4 times 4 plus 5 times 2 divided by 36, which is 10 plus 16 plus 18 plus 16 plus 10 by 36. 10 and 16 is 26. 26 and 18 is 34. 44. 44 and 16, 50, 60, 70 by 36, which is equal to 35 by 18. Let us have a look at the options. This one, fourth. Now let us have a look at the fourth problem. If getting a head on a coin when it is tossed is considered as success, then the probability of having more number of failures than when 10 fair coins are tossed simultaneously is. So he's saying 10 fair coins are being tossed simultaneously. You can toss them simultaneously or one after the other. It doesn't make any difference because all the coins are separate. So the result of one being tossed after the other or being tossed simultaneously makes absolutely no difference. I can toss two coins simultaneously or one after the other. The result won't change because they are independent coins, right? So tossing them simultaneously or one after the other is absolutely no difference. Anyway, we have 10 fair coins. What is a fair coin? A fair coin, like I have defined fair dice above. Let us look at a fair coin. A coin has two faces, head or tail. Fair coin says the probability of head is equal to the probability of tail, which are both 50%, that is 1 by 2. Like if you have seen the movie Sholay, Amitabh Bachchan had a coin. It was not a fair coin. Whenever he tossed it, he always got head. That was an unfair coin. But here we are given fair coins. The probability of head is equal to the probability of tail, which is equal to 50% or half or 0.5. So he's saying when you toss a head, it is considered as success. When you toss a tail, it's called as failure. Now when you have tossed 10 fair coins, you want more failure than successes. More failures would mean more tails. More tails. So when you have 10 coins, you can get 10 tails, 0 heads. Since head is considered as success, tails is considered as failure, so 10 is greater than 0. So this will be considered as a more failure and less successes. So this will be considered 9 tails, 1 head is also considered, 8 tails, 2 heads will also be more failure and less success. 7 tails, 3 heads will also be there. 6 tails, 4 heads. more failures, less successes. What about 5 tails and 5 heads? Equal number of failures and equal number of successes. So this will not be considered. What about 4 tails, 6 heads? More success, less failures. So this will also not be considered, and remaining will be not considered. Remaining are 3 tails, 7 heads. This will not be considered. 2 tails, 8 heads. Not considered. 1 tail, 9 heads. Not considered. 0 tails, 10 heads. This will also be not considered. The events that will be considered are these ones. So I have 10 tails, 0 heads, 9 tails, 1 head, 8 tails, 2 heads, 7 tails, 3 heads, 6 tails, 4 heads. I have to find out how many ways I can get this. So the total number of ways in which I will have tails and heads when tossed 10 times will be 2 raised to the power 10, right? When I toss it 1 time, there are 2 possible outcomes. 2 raised to the power 1, that is 2. That is either a head or a tail. That's it. When I toss my coin 2 times, the outcomes are 2 raised to the power 2 is equals to 4. How will I get 4? Either head head, head tail, tail head, tail tail. Similarly for 3 I will get 8, so that will be head head head, head head tail, all the way up to tail tail tail. So 8 times. So for when I am tossing it as 10 times, the total outcome will be 2 raised to the power of 10. Now I have to find out the number of ways in which I can get 10 heads and 10 tails and 0 heads. So tail, 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 tail. 10 tails. Only one way to express this. So one way for 10 tails, 0 heads, 1. Now I have 9 tails and 1 head. How many ways can I do this? It's the same as choosing 1 out of 10. 10C1. Right? If you want to calculate 10C1, this will be 10. If you want to see it dramatically, you can do this tail, 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 5, 6, 7, 8, 9, 10. So head here, this is one way of expressing 9 tails, 1 head. Second time, head will come here, tail will be there, then head shifts here, 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 here. Total number of ways in which you can get 9 tails and 1 head is 10C1, which is 10. Now 8 tails, 2 heads. This will be 10C2. What is 10C2? 10 into 9 into 8 factorial divided by 2 into 8 factorial. So 5 times 9. Right? 10 times 9 by 2, which is 45. Now 7 tails and 3 heads. Again this will be 10C3. You can get 7 tails and 3 heads in 10C3 ways, which is 10 times 9 times 8 times 7 factorial by 3 factorial is 3 times 2 and 7 factorial here, which will be cancelled. So 2 times here is 5, get 3 here. 5 times 8 is 40, 40 times 3 is 120. So 7 tails and 3 heads, 120 ways. Okay, the last one is 6 tails, 4 heads. You get this one in 10C4 ways, which is 10 times 9 times 8 times 7 times 6 factorial divided by 4 times 3 times 2 times 6 factorial. This get cancelled. 4 times 2 gets cancelled with this. 3 gets cancelled with this. 7 times 3 is 21 times 10 is 210. So the total number of events for more failures and less success is 1 plus 10 plus 45 plus 120 plus 210. That is 1 plus 10 plus 45 plus 120 plus 210. How much is it? So 120 and 210 is 330 plus 45 and 10 is 55 and 1 is 56. You add it, you get 386. So the total probability of more failures than successes when the coin is tossed 10 times will be 386. By the total possibilities is 2 raised to the power 10. So 386 divided by 2 raised to the power 10 is the answer. 386 by 2 raised to the power 10. Okay, now you have to be careful. This is 638, not 386. So don't mark this one. I have my answer as 386 by 2 raised to the power 10. It doesn't match any option. If I divide by 2, I get 193 divided by 2 raised to the power 9. So this one. Don't mark 638 by 2 raised to the power 10 because it looks like this. And sometimes people are in a hurry and they will mark this option, which they will get no fruits for all the efforts you have put in. You get 386, 2 raised to the power 10. And then you see this, oh, it looks similar. Don't mark this. This is the correct one. Okay, so I think we are done here with this probability problems. We will cover another video in another topic in the next video.